What's up, everybody? Mr. Fortin here from the garage, filming you a series of 3 math videos that all have to do with solving systems of equations. Now, I normally teach systems of equations in Algebra 1, so in case you missed that class, hopefully you had an Algebra 1 that covered systems. No, I'm serious. Algebra 1 is a major content area in Algebra 1. And you learn it first semester, you learn it fall semester. So that was before the pandemic. You had questions on the fall final about it. Hopefully you know how to do it. But if not, I'm sending you the message this year in geometry. And if you're in Algebra 2, you also know this too. Some people double up Algebra 2 geometry. Systems aren't going anywhere. Got to know how to solve a system of equations. And although we don't have time to really spend days of lessons teaching you how to solve systems, kind of the simple systems you have to do here in geometry, you should still know how to do them. And you should still do outside work in case you forgot how to solve a system, or perhaps your teacher, for whatever reason, didn't spend that much time teaching you how to solve the system of equations last year. It's a pretty big thing. So I will go over it, and I hope you watch these videos in case you forget about this or need a refresher or just want to make sure you know how to do this, because this came up on this problem number 22, and it's also come up on several problems so far this year. And that is, how will you solve a system of equation? Okay, when a system of equation is here, let's check it out here. We're working with these two things, these two equations, in these 3 videos, right? So that's not going to change. What's going to change is going to be the methods that we solve them. There are 3 methods that ideally you learned in Algebra 1 about solving a system of equations. But the first thing that we might want to mention is, what exactly is a systems of equations? Well, equations is plural, so that means there's got to be at least 2, okay? At least 2 equations. There we go. I got equation 1, equation 2. And those 2 equations, they share the same variables, okay? So a system of equations is a set of 2 or more equations that use the same variables, have the same variables in them. And oftentimes, you're able to solve those equations, okay? And what that means is you're able to find the solutions for x and y in this instance, or the solutions for whatever variables that are being shared between the 2 equations. You're finding solutions for those 2 variables, or 3 variables if there are them, that would make one equation true and simultaneously make the other equation true, okay? So we're gonna wind up with one set of answers. One in this situation, at least this one's, I've done it already, there's gonna be one answer for x that's gonna work here, and a corresponding answer for y that's gonna work in both of the equations. We're just gonna get one x value, one y value in this particular problem. So video number 1 is this: solving systems by the equal values method. So welcome. I'm glad you guys are watching this equal values method, because that's a good one. And somebody in block 3 actually presented this very problem here doing the equal values method. So hopefully block 3 got a little heads up on this here. All right, so if you're doing a problem like this, we got a systems of equations. I got an equation here and an equation here. Just to remind yourselves of where that came from. That came up in the premise of this problem. What values must x and y be to make quadrilateral JKLM a parallelogram? Well, we know this thing here, if it's going to be a parallelogram, then potentially that what would be required of that is that the opposite sides here, JM, has got to be congruent to KL, right? KL here. So here we have JM right here, and that's 3x minus 2y, and that has to be the same length as its opposite side in order for this to be a parallelogram. So 3x plus minus 2y is got to equal 26, right? That's it right here, okay? These got to equal each other right here. These got to equal each other, and that's one equation. And then the other sides, the opposite pair, the other opposite pairs of the sides in the parallelogram, if we knew that those opposite sides are congruent here, those opposite sides are congruent here, then we would know that it would have to be a parallelogram. Okay, so what this question just really has to do is how do we apply this geometric principle that if we have opposite sides, right, these are going to be equal here, right? 4x plus y equals 42, right? We have this principle that if you have opposite sides of 2 pairs of opposite sides of quadrilateral being congruent, then the quadrilateral has to be a parallelogram. How you can apply that to an algebra problem. And that simply is, right, knowing what congruency means is the same side lengths. Congruent segments are defined as segments that have equal lengths. So just set it up so that these sides here are equal to each other in length, the opposite sides, and then boom, you end up with one equation, 2 equations. Okay, take a second, make sure that that's set in, make sure that makes sense here. Okay, so we got all this information up here. JK and LM are opposite of one another, right? So that means that, right, JK is right here, 4x plus y, got to equal, and then LM is over here, got to equal 42, so 4x plus y equals 42, and then the other way around too, right? MJ, right? MJ and KL would be opposite of one another. So 26 has got to equal MJ, got to equal 3x minus 2y. And that's what we have set up there. All right, so that's the setup of the problem. And here, I haven't really told you the way that I'd solve this yet. We're going to use this thing called the equal values method, but I just want to make sure you have that clear because the 3 videos I'm filming for this, it sets up the same way, okay? Got to know that these opposite sides are equal to each other in length, okay? Opposite sides equal to each other in length, and now we have one equation, we have a second equation, okay? So if you're watching this video, you're like, Mr. Fortin, I get it. Let's go ahead and solve this, okay? Let's do it ahead together, and we're going to do that through the equal values method. Okay, so equal values method is the method of solving systems that, if you had me last year, is the first thing that we did, first way that we solve things. And it's very similar to the transitive property of equality, okay? Because remember, we have an equation here and we have an equation here. The way that the equal values method works is if we isolate one of the variables in both of the 2 equations, okay, let me just tell you what it's all about here. Equal values method to solve this. If we isolate one of the variables, that means get the variable by itself, okay? So I'm going to subtract 4x here, because I'm going to isolate y. Y equals 42 minus 4x. Okay, so that's one way I can rewrite this equation. I'm legally allowed to do that, right? That's just the subtraction property of equality, okay? I'm just doing the subtraction property of equality. If I take away equal values from both sides, then equality is preserved. And taking away equal values, that's just subtraction, so that's subtraction property of equality. Okay, if I'm able to do that, I get y isolated by itself. There it is. That's the key thing, right? Y equals this, right? Y equals this. Okay, so if I'm using the equal values method of way to solve for at least one of my variables here, if I isolated y here, okay, I can remember through transitivity, right, that things that each equal the same thing are equal to each other. Okay, that's the way that Euclid worded that one out 2,300 years ago. But anyways, if you're new to me this year, and you didn't have it last semester, I say that a lot, right? I say that a lot when it comes to transitive. So if I can get a different expression that is equal to y over here, I can take my 2 expressions, set them equal to each other, because I know they'll both be equal to y. Okay, so that is sort of the idea of the equal values method. We're going to do it here, and you should remember the steps. If you're just like, okay, this is the solving method for me, this is what I'm going to do. Okay, so in this problem here, I'm going to get y by itself, because if I can get y by itself, then again, right, 2 things. So y equals 42 minus 4x. The question is, what else does y equal? And then we can set those 2 things equal to each other. And that can help us solve. You'll see it in a second. Let's just get done with it here. All right, so there we go. So I use the addition property of equality to get rid of that negative 2y. So now I got my 2y over here. That's good because I want to isolate one single positive y. Okay, so I'll at least make my y positive over there. Okay, so now I have 3x is equal to 26 plus 2y. I'm going to now subtract, so now I want to isolate. Remember, I'm trying to isolate y. I got y alone over here. I'm going to y over here alone in the second equation. So I'm going to subtract 26 from each side, and then I get 3x minus 26, and that's equal to, well, these canceled out, so I got this 2y left here. And now what can I do to both sides? I can divide both sides by 2. I can flex the division property of equality. Divide by 2, yoink, yoink. So 2 y's are split 2 ways to get to this 1 y, and that's what we wanted to do. We wanted to isolate y over here. So now we got y equal to another expression here, which is 3 over 2 x minus 13, right? How to get 13? Well, negative 26 divided by 2 is negative 13. And we're set up here, okay? So here, I'm doing my first method. Again, this should be a review from Algebra 1. I actually haven't taught this in Algebra 1 yet this year because we're so behind where we normally are, right? It's usually like an October or November topic in Algebra 1. So I'm just starting teaching that actually in 2 weeks. I teach this in Algebra 1 class. So if you're in Algebra 1 right now, you may have never seen this before. But the idea is, hey, check it out. Look at this. I have rewrote this equation to isolate y here, and I had already rewrote this equation here to isolate y over here. And now we can put on our thinking caps from geometry in that, well, I got y equals to this here, y equals to this here, and they both equal y. Look, what do we know about 42 minus 4x? What do we know about 42 minus 4x? Well, it equals y. What do we know about 3 over 2x minus 13? Well, it equals y because we had done properties of equality to justify that. Starting with this equation, it's got to equal this if we're trying to get the quadrilateral to must be a parallelogram here, okay? So what I can do here through the equal values method is this. I can take this, and I can take this, and I can do the equal values method because 42 minus 4x and 3 over 2x minus 13 are equal values. They're both equal to y, right? Both equal to y. So there's a value that they're both equal to. That's why it's called the equal values method. So what I'm going to do is I'm going to take that 42 minus 4x and take that 3 over 2x minus 13, and I'm going to set that equal to each other. Is this ringing a bell? You should have maybe seen this a bit in middle school as well too. There's really only one method called the elimination method, which I'll do a video of later, that really you shouldn't have seen that much of in middle school as well too. But remember, systems, they don't go anywhere, right? And that's part of the reason why we hope to review this with you almost every year, right? Starting in middle school, and then Algebra 1, you got some review, and hopefully you got pretty good at it. And then geometry, so this is a bit of a review, and hopefully you're getting caught up if you feel like you didn't do it that well. Okay, so check it out. I'm using the equal values method here, and now what do I notice? Okay, what do I notice? So now my only variable is x in this equation. And that is wonderful. That is lovely because my only variable is x in this equation. So what can I do? I can solve this equation, right? I can solve this equation. I couldn't have done that. Like, you probably panic a little bit. I said these equations. Wait, how do I figure out what y is? How do I figure out what x is? I got x and y in the same equation, x and y in the same equation. Here, I only have x in the equations. So now I can solve for that x here. So I just need to flex my properties of equality, right? Make sure you know how to do this here. Okay, so why don't I actually move my x's over here, because my x's are positive here, they're negatives here. So I'll collect my variables, make it really positive over here. So this is 4 over x. We can think of 4 over x as being 8 over 2. You can maybe think of that, right? 8 over 2 is the same thing as 4x, right? 8 divided by 2 is 4. So I'm going to think about doing it that way. And then I'll move my 1s over here, right? Move my constants over here. So let's get rid of that 13 and move it over here. Yoink, yoink. Those canceled out. So here I'm doing my property of addition property of equality, and I'm adding equal things. I'm adding 4x plus 13 to both sides, or 8 over 2x plus 13 is the same freaking thing. So let's set this one up here. We got 42 plus 13 is 55, and that's going to equal, let's check it out here, 3 plus 8 is 11, and then that's all over 2x, okay, all over 2x here, okay? So now I want to solve this, right? Now I want to solve this. One thing I can do maybe to actually make my life a little bit easier, get rid of that fractions, I'm going to multiply by the reciprocal over here. So I'm going to multiply by 2 over 11, multiply by this. Should I have done that way? No, I don't want to do that because I get fractions over here. Or maybe not. I could do that. I could do that over here. Here, I want to get fractions over here, and I get 2 over 11 over there. Okay, so here, not to confuse you, this is kind of confusing here. So here, this is 55 divided by 11, right? What's 55 divided by 11? That's 5, right? 5 times 11 would be 55. So that's 5 times 2 gets us to 10, okay? Gets us to 10 here. So in here, 11 divided by 11 cancels out. That becomes 1. 2 divided by 2 cancels out. That becomes 1. So this is just 1x here, okay? So my answer for this one is 10 for x. Now I go back to the beginning of the equation, okay? Go back to the beginning of the equation, and it says here you got to find what values must x and y be to make this a quadrilateral, a parallelogram. Well, 10 would be the x value. We need to figure out what y's got to be, right? To make that this here, right? 4x plus y needs to be 42. Okay, KJ needs to be 42, and also too, x is going to be 10 here. What's the value of y going to have to be to make JM equal to 26, right? What's it going to have to be? And in order to do that, we go back to one of our original equations. Okay. So what I'm going to do is I'm going to plug in 10 for x to one of the original equations and solve for y. All right, so what I'm going to do is, let's take this here, 4x plus, so here, 4x plus y has got to equal 42. And we just need to figure out what the corresponding value of y is going to be that's going to make that equation true. And we know that 10 is going to be our solution for x, so I'm going to plug that in here for our solution for x, right? We already solved for that. 10 is going to be the common solution in both those equations. We can do the other one quickly in our head afterwards. And now we just got to solve for y. And check it out here. 4 times 10 is 40, plus y equals 42. And there you go. This is going to be 2 here, right? 40 plus 2 equals 42. Or I could subtraction property of equality it if you want to just be super structured with it. 42 minus 40 is 2. And we're good to go. Okay, so this is my solution. All right, solution. You remember this one from Algebra 1? Come on, guys. Remember this from Algebra 1? You write your answers as a pair of coordinates. Remember that? 10, 2. That might be one way that a mathematician's writing their answers is, I'll just write it as coordinates and you're good to go. Okay, those are the values of x that make this true, and we can even double check it in our heads here. 4 times 10 is 40, and then plus 2 is 42. We already knew that because we already used that to solve for y equals 2. So let's check it here to make sure we're true here. 3 times 10 is 30, minus 2 times 2, right? And that's 4, so 30 minus 4 is 26. And we're good to go, right? We're good to go. Okay, so I might even show that out, right? You can check in other equations because the idea is you're finding the common values of x and y that make this freaking little parallelogram. So this one here has to equal 26, right? 3 times by 10 minus 2 times by 2 has got to equal 26, right? Because we had that other equation was 3x minus 2y equal to 26. And indeed it is here. 3 times 10 is 30, minus 4 equals 26, and 30 minus 4 is 26. 26 equals 26, and we're good to go. We know that our solution is correct. Hopefully you enjoyed watching this. I'm going to show you 2 other ways to do this in 2 more videos because, hey, this might be a lot to remember, but if you can focus on this being like, okay, this is what the equal values method is, so perhaps when I do the substitution, I'll do the equal values method, or I'm going to give you a choice. I'm going to show you the substitution method next, and then after that, in our final video, I'll show you the elimination method. Sometimes it's better to become better at, more capable and confident at solving these systems of equations problems if you know that there's more than one way strategy, right? One more method that you have here. Okay, so it's not enough for me to show you this, even though this will help you solve a lot of systems. I want to show you other ways so that you get faster and more confident in the future. Email me if you have any questions. Thank you for watching this first video. Stay for video number 2. It's gonna be a good time. Bye.